Let's look at an example of OWL 6.2. In this problem, you're given the mass of solute magnesium acetate, and the formula for magnesium acetate is MgC2H3O2 taken twice because of the acetate ion having a negative 1 charge, and magnesium ion having a positive 2 charge. All right, if we calculate the molar mass of magnesium acetate, we get 2.41 grams per mole. We need that to convert grams to moles. All right, so to solve for the molarity, we've seen in the previous problem that molarity is moles per liter. And so we need to calculate moles from the grams and the molar mass. So I'm going to take the 24.7 grams and I'm going to divide it by the molar mass, 142.41 grams per mole. And as you can see, your grams will cancel out and you are left with moles, which is what we were trying to calculate. In the denominator, we put the volume in liters. 375 milliliters is equivalent to 0.375 liters. And when we plug all of that in, we get 0.463 moles per liter. That is the molarity of the salt magnesium acetate. In this problem, we're also asked for the concentration of the ions. So we use brackets to represent molar concentration or molarity. So we want to calculate the molarity of magnesium ions. Well, when you look at the formula, you see that there's one magnesium ion for every one salt. Okay, so let's look first at the formula. There's one magnesium in that formula. There are two acetates. Therefore, the concentration of magnesium ions will be equivalent to the concentration of the salt magnesium acetate. And that will be the value we just calculated, 0.463 moles per liter. Will the same be true for acetate? Let's take a closer look. The concentration of the acetate ions, will be not equal to the concentration of the salt. We have two acetate ions for every one salt formula. So if I were to dissolve magnesium acetate in water, it would dissociate into one magnesium ion and two acetate ions. Use the subscripts in the formula to figure this out. So I'll say, okay, there are 2 moles of acetate for every 1 mole of magnesium acetate. And then I would multiply that ratio by the molarity of 0.463 moles per liter. And I'll get, let's see what we get when we multiply 0.463 times 2. We get 0.926. So while the molarity of the magnesium ions was equivalent to the molarity of the salt, the molarity of the acetate ions was twice the molarity of the salt.